Welcome everybody, and thank you for joining this IoT Sparks live webinar. Today we are talking about a very interesting topic. We're talking about switchgear digitalization, and we will see in this webinar, then with our experts, how we can, let's say, face the challenges and the issues that this environment, this sector suffer from. And it's very interesting, especially for me, as I'm very passionate about IoT, where it combines a financial impact, positive financial impact, and environmental impact. And this is exactly the case. In fact, as you will see during the webinar, there is a specific issue with FSX gas that are very, very dangerous for the environment. So at the same time, with this solution, you will be able to address both cost problem issues, operational issues, and also environmental issue. And as we move forward in the webinar, I will, and before introducing our speakers today, I would like to remind you that you have the chat and Q&A tools. You should see them in the top bar. So in any moment during the webinar, you can write your question and they will be answered at the end of the presentation. So let's move forward and let me welcome our speakers. Dirk-Jan Cotier from WIKA is an experienced salesperson since more than 25 years, and over the last years is very focused on solution in the energy industry, and specifically he is sales director of WeGrid. That is WIKA solution for substations for Europe, Middle East, Africa, and India. Correct me, please, if I'm wrong. And you can also see Ingi Diego, my colleague here at LORIOT, and he is business development manager, a keynote speaker, as he talked to several events in the past, and of course also our expert regarding the network management system and so on. Without any further ado, I hand over to Dirk-Jan. Welcome again, who will start the presentation. See you later.
All right, thank you very much, Dario. And also warm welcome from my side, of course. First of all, I want to take a closer look at today's megatrends, because if we look at switchgears, power and utility market itself, we see that there's a lot going on in the market at the moment. So first of all, we have the decentralization. The decentralization, it's all about connecting the numerous renewable generation plants. And because today we can see a lot of investments going on into the renewable energies. But it's also the demand for the electrical vehicles that needs to be charged. We are talking about the electrolyzers. We are talking about the grid batteries. And because the global demand for electricity is growing, it's growing very fast. And therefore, we need to have more connections, more grid connections. We need to have more substations. The next part is the decarbonization. We see a global climate change, and we are all talking about sustainability. We are talking about how to reach our sustainability targets. And here we have the Paris Agreement. The Paris Agreement is just being updated, and there's a clear statement in the new Paris Agreement that we need to achieve zero CO2 emissions by 2050. And again, it's related to the increasing demand of energy, renewables, but it's also about safety. How can we work in a safe environment on switchgear level, and not only locally, but on a global scale? And then, last but not least, it's the demographic change. According to the latest calculations, we will have around 10 billion people on our planet in 2060. It's a growing number of elderly people. So coming back to the switchgear, how are we going to operate and how are we going to maintain our switchgears? How are we going to maintain all the substations? And we also see an increasing demand in our infrastructure related to energy, to water, to food, and due to the urbanization. So the question here is, how can we cope with these situations, with all the trends, the mega trends that are going on in the market? And there's only one keyword here: digitalization. With the help of the digitalizations, we are able to cope with our substations. Because if we look at the substations, the substation is the key element of the grid. No matter how the power is generated by all the different generations that we have, the different segments that we have. So from the transmission to the distribution to the power that we have available on our daily scale, there is the need for the substation. This is the key element of the grid. What kind of substations are we talking about? We are talking about indoor gas-insulated switchgears. We are talking about outdoor substations, air-insulated switchgears. We are talking about all different types of gas circuit breakers. We are talking about offshore substation. And especially the offshore substations is a fast-growing market. And we can see all the investments that are done for the renewable energies. And if you keep in mind that in each and every windmill, there is a medium voltage substation. And this medium voltage substation contains SF6 gas, and depending on the switchgear that is inside, it can also be air insulated, can be vacuum technology, different kind of technologies. But these windmills and these switchgears, they need to be monitored. Who is going to do that? How are you going to do that? So it needs to have a digital solution. And then we have different kinds of gas insulated transformers. And last but not least, we have the ring main units, or better known as RMUs. So all different kind of substations that we see in the market. When we go back to the market trends and we look at today's situation, we all agree that the high voltage grid is very critical with an increase in complexity. And besides these aspects, 100% availability of the grid is a must. And to check the status of the assets in the field, a lot of manual work is needed. The transmission and distribution system operators, they are dealing with unplanned shutdowns and undetected leakages of SF6 gas. And as part of your sustainability program, you want to reduce these unplanned shutdowns and leakages to achieve your goals. Tomorrow's situation is that we will focus on condition-based maintenance. We will focus on condition-based monitoring and get away from the time-based maintenance. Real-time monitoring of your assets An early stage warning is part of the daily routine. An easy to use and cost-effective solution with a full remote monitoring for 24/7 visibility, which will increase your health index, the health index of your installation. What are today the two main challenges or main drivers when it comes to SF6 gas? The first one is leakages. The root cause of these leakages are aging of the O-rings, aging of the sealings, impure sealing surface. And the problem is, as soon as there is a leakage of SF6 gas, it will stay in our atmosphere. And it will stay there for more than 3,000 years. And when you look at the sustainability and the reduction of the CO2, we need to keep in mind that the global warming potential of SF6 gas is 23,000 times higher than CO2. So every loss of SF6 gas will have a huge impact on our environment. And right now, the most common classic detection is that we have the gas density monitors with the alarm, with the contacts. And the effect of this is that we will have the leakages, the leakage detection in a late stage. So what we want to have is an earlier stage detection. And we want to have 24/7 visibility, 24/7 availability of the data. And the other challenge that we see is the humidity. Humidity inside the compartment, which has a high effect on the quality of the gas. And the root cause of the humidity inside the compartments is diffusion through the materials, unsuitable SF6 gas handling. And the problem with the humidity inside the gas is that it will change the density of the gas. It will change the composition of the gas because it is decomposing. And when you have the decomposition of your SF6 gas, it can create an acid atmosphere. It can cause corrosion inside the compartments, which will have negative side effects. So a trending of the humidity over a defined period of time, it's almost impossible. When you look at the switchgears, we know that the average lifetime of the switchgear is between 30 and 50 years. And when you take a look at the curve over here, you can see that there is an increase of SF6 related failures after 15 to 25 years. And we know, based on the data that we received from one of the biggest European transmission system operators, that more than 56% of the installed base is older than 15 years. So that means that all the substations from the beginning of the year 2000 are becoming more and more critical in a shorter period of time. So we need to have a clear focus on these aging substations. What is the technology transformation when it comes to IoT? Until today, there is a lot of activity-based information. There is a lot of active, reactive work is done. That means that for the density, the gas density monitoring, they have their alarms, they have the contacts, but also the technicians need to go into the field and do the manual reading of the gas density monitors to read the pressure, to write it down, to create the report. So that means a lot of actions need to be taken. And the same with the humidity. You need to do a gas analysis between every 1 and 6 years. But if you do it today, what is happening tomorrow? What is happening next week, next month, next year? Nobody knows. So you need to have a more proactive systems. You need to have 24/7 availability of your data. You need to have an early stage warning if the density or the pressure or the temperature or the humidity is changing. So when the condition of the gas, SF6 gas, is changing, you need to have an early stage warning. So you need to have live measurement data. You need to have the forecasting. Because with the forecasting that WIKA is providing with the solution, you are able to predict when you need to schedule your maintenance. So it's not time-based maintenance anymore. It is now condition-based maintenance. So that's a completely different approach when it comes to maintaining your substation, to maintain your switchgear. If we now compare a digital solution against the conventional gauge, you will see huge differences because the conventional gauge can detect 5% of the losses, and a digital solution can detect 0.5% of the losses. What does that mean? If you just compare a small compartment of 60 kilograms filled with SF6 gas, you can achieve a savings of 4.5%. That means for a 60 kilograms filled compartment, you can save 0.72 kilograms of SF6 gas. 0.72 kilograms of SF6 gas doesn't sound that much. But if you take into consideration that this amount of SF6 gas is equivalent to more than 136,000 kilometers that you can drive with your car. You can save almost 1,000 euros on your CO2 certificates. You can save more than 6,000 euros based on your emission. So based on the environmental aspects. And to compensate this small loss of SF6 gas, you need to plant 1.25 acres of forest to compensate for the CO2 emission. So if you look back at today and towards the future of our children, we can help them, we can support them, but we just need to act. So what does that mean? Just as a simple overview. With the IoT digital monitoring solution, we install our sensors. And here, sensor number 1 is a unique sensor. It's based on wireless communication, wireless technology. You don't need to power up this sensor because there is a battery inside. And the sensor, the communication, is based on LoRa technology. LoRa, wireless area network technology. And besides the wireless sensor, we have 2 different types of sensors which are hardwired based on Modbus output. And these sensors are installed in the switchgear. And from the switchgear, the data is transferred via a gateway into a dashboard so that you will have 24/7 visibility and availability of your data. As you can see, we offer our monitoring solutions for the high and medium voltage gas insulated switchgears. Not only for SF6 gas and air, but already also applicable for alternative gases. So we are fully prepared for the future developments that are coming. And for the air insulated medium voltage switchgears, we up to 66 kilovolts, we are able to supply online temperature monitoring in combination with partial discharge. And the fourth monitoring solutions that we are offering is room monitoring of SF6 gas. because in some cases you have an indoor gas insulated switchgear. And the room monitoring is literally detecting if there is any leakage and SF6 gas in the enclosed environment where the gas insulated switchgear is installed, so that we are secure and know for sure that it is safe for the technicians or for us, for people, to go inside this closed environment. And all the data communication goes via Modbus, RTU, or the LoRaWAN output signal, and the data is visualized in a cloud server or a web dashboard. And with the LoRaWAN technology, you have the advantage of saving additional wiring cost. How does the system architecture look like? And because on one hand side, you have your sensors, but you need the data from the sensors into a dashboard, into your own IT infrastructure. So therefore, we have two solutions. The first one is the cloud-based solution, and the second solution is the on-prem. So with the on-prem solution, all the data stays on premises of the substation, of the switchgear. And with the on-prem solution, we are offering a completely containerized solution based on the Docker technology. So it's based on the analytical microservice. And with the Docker solution, we literally put the analyzed data inside this enclosed environment, inside this container. And we give you the key to open up the door of this container, take the data out, and transfer the data into your IT infrastructure. So different kind of solutions that we are able to offer. So it's not only on a component level, on a sensor level, it's the complete solution from sensor to the connectivity to the cloud or on-prem solution. I already mentioned it. We want to have 24/7 availability of the data. So we need to be able to visualize it. And therefore, we are supplying a dashboard. And with the dashboard, you have a clear view of all your substations, of all your switchgears. Where are they located? And as soon as you click on one of the green buttons, in this case, on locations, you will look into your substation. You will look into your switchgear. And you can go on a very detailed level, on a bay level, on a compartment level, and you will have in one eyesight see what is the condition of my compartment, what is the condition of the car SF6 cars or alternative gases inside my compartment. What are the benefits when it comes to digitalization? First of all, it will increase your operational efficiency because you can reduce your reading, reduce the switching, and it will have a substantial OPEX savings for you. It will reduce the service and maintenance costs. It will have a positive effect on your regulation and sustainability. And because you will have avoidance of SF6 gas leakages. And the reporting is done regularly. And it will improve your risk management. And last but not least, and maybe the most important one, it will increase the staff and plant safety because it will simply reduce the exposure of personnel and sensor and to the sensor locations. So these are the 5 main benefits that you will achieve by digitalization of your switchgear, by implementing an IoT solution. But what is a solution without a network? Because you need to be able to transfer and the data. And that is a point where I want to hand over to Ingi. and he will bring you fully up to speed when it comes to the networking part.
So thanks, DJ, for that presentation and the great summary of how WIKA solution is addressing the challenges caused by the decarbonization, population increase, and that in the energy grid. All right, let me take over here 1 second. Yeah, as DJ highlighted, our webinar aims to shed some light on tested solutions that empower companies to develop digitalization strategies. Specifically, we're focusing on engine turbine operators, digital substations, and the roles of the TSO and DSOs in that. We identify these areas as having immense potential in driving the sustainability practices towards ambitious climate and energy targets. Typically, when we start with one of these sort of projects, we like to assess the pain points that the clients are having and how they want to address it. They want to get the right stakeholders involved early in making sure they take the decision on the best strategy forward for them and their roadmap. Most of them want their data insights on site, and the ability to build and manage your own infrastructure is a key enabler for digitalization of power systems, as it provides that security and that flexibility needed. So we can see here in our first slide, the communication pathway, whether you're looking at LoRaWAN or mioty, you have devices here that are broadcasting their message out into the open air, and any gateway that's within range will receive that message, gateway or base station, and send it to the LoRaWAN network management system. And then that information will then be sent up to the applications and platforms where you can make sense of the data by dashboards and things like that. So this one you see here, we have bidirectional communication. We have that, and then the LoRaWAN network server is the brains of the operation. It's the one that checks that the device does belong to the network. It makes sure it has the correct spreading factor and ADR, things like that. And then that information is converted into whatever type of application output you need, like HTTPS, MQTT, WebSocket. And that information then goes up to your applications and platform where you can ingest that data and make better decisions. So why are many companies using LoRaWAN for this? Well, LoRaWAN stands for long range, and that sort of long range that's being used on the ISM bands are duty-free bands. So you can build your own network when and where you need it, and you don't have to rely on cellular providers. The LoRa technology is well suited because it provides the most efficient means of transporting data up to 20 kilometers in rural areas and 2 to 3 kilometers in cities. LoRaWAN is also chosen for its great penetration and resilience to interference. When you have large obstacles, buildings, things made of concrete and steel, you need a radio signal that can penetrate through that while using very little energy. Regarding security, LoRaWAN uses embedded end-to-end AES 128-bit data encryption. This delivers the high-level privacy and protection that customers need, and it's the same sort of encryption that's used by ChatGPT and Google's web servers. It's estimated that even with all the computational power on Earth combined, it would still take billions of years to crack AES 128 through brute force. But on top of that, the devices also regenerate the keys with every time they're being power cycled. The LoRaWAN can use a lot less power than other comparable technologies. You're talking about 1 microamp in sleep mode and battery life of up to 10 years in certain scenarios. Another point in LoRa's favor is a wide ecosystem and quite a variety of devices on the market. For instance, there are bridge products, which allow you to use legacy sensors or actuators and essentially make them into LoRaWAN compatible devices, helping you get the data out of the field and into your data lake. For example, you can connect RS-485, Modbus, 420 milliamp analog or digital interfaces to these bridge devices, and they'll receive the information and transmit it wirelessly over LoRaWAN, helping you to avoid complications with cabling and things like that. mioty is a bit similar to LoRaWAN, but it's all about scalability and the capacity that it has. So a mioty base station can receive 3.5 million messages per base station per day and up to 150 telegrams simultaneously. It's because of the efficient design of the telegram splitting that this allows for shorter transmission time with less interference and less battery use, less duty cycle usage, all of this helping to mitigate packet control loss and retransmissions, which means mioty offers extended battery life, with up to 20 years being a real possibility. So that's nice to know about the LoRaWAN and mioty and how it can do this wirelessly, but many customers want to know how is this going to affect their SCADA systems. So this is the Purdue model for SCADA, the supervisory control and data acquisition. It's the framework they use in industrial control systems with critical infrastructure and manufacturing environments. For instance, if wind speeds get too high for your wind turbines, your SCADA system might shut them down to prevent damage. SCADA is the command and control system for your plant. And for good reason, companies are very hesitant to touch a running system. One of the biggest hurdles to digitalization is the cost of getting the data via wired sensors through the pyramid. It's incredibly expensive. Adding one new measuring point into the SCADA system can cost between 5 to 10,000 euros and require mandatory documentation. You have to get many stakeholders involved, and you have to get approvals and sign-offs. That means that remote assets that were not monitored in the past will probably remain unmonitored, perhaps only being checked during routine maintenance. But what if you could retrofit existing assets with affordable LoRaWAN sensors to wirelessly get the data over long distances and ingest the data into the data lake without downtime and without ever touching the SCADA system? LoRaWAN solutions and infrastructure costs are very efficient, and they don't disrupt the current setup. If you choose to, you can use OPC UA and map the sensors to your SCADA system, and you get the LoRaWAN payloads into your SCADA system, and you can do this securely and on-premise. Your data remains on-site. All of these components work together to finally give you visibility of previously unmonitored assets. The remote monitoring also means you're not just getting a snapshot of system performance on a particular day at a given hour, but we give a full history of the hour-by-hour performance of your assets, giving you greater insights for better decision-making. Since service and maintenance costs are exceptionally high and on-site visits increase the risk of accidents, by remotely monitoring your assets, you can improve the lifespan of your equipment. You can reduce downtimes, you can improve efficiency and energy savings, and have predictive maintenance and advanced warnings of potential problems, getting warning before they actually happen, not reacting on just a reactionary basis. We want to enable people to predict, preemptively act, and protect their assets. Once the decision has been made to monitor your assets using LoRaWAN or mioty solutions, you can then leverage the same existing infrastructure to help them solve other pain points. So perhaps you place your gateways or base stations at a site to monitor the SF6 gas switchgear in a wind turbine, for example. You can then easily bring in other solutions to work in parallel. We have some customers using LoRaWAN for intruder detection in secure areas, weather stations, the oil leak or level detection on these wind turbines, corrosion, etc. For instance, our partner Assystem in France is combining sensors and embedded intelligence to prevent the breakdowns of industrial equipment. This can be used on wind turbines, for instance, to detect rotor and gearbox malfunction early on and prevent downtime. They have the world's first triaxial vibration sound and ultrasound sensors that work with AI and machine learning to give you the earliest possible alerts of any drift or malfunction that may be coming. Fusion of vibration and ultrasound measurements, along with the surface temperature of the machine and the ambient temperature and humidity, means they don't just predict industrial equipment failures, but also help to determine their root causes. But this information is also invaluable in process optimization. If you're analyzing wind turbines or hydroelectric performance, you're going to want to know the output power of the turbine in watts, the rotation speed of the turbines in revolutions per second, the wind or the flow, the speed in meters per second, maybe the ambient air or water temperature as well. Usually as equipment begins to age, we want to take a proactive approach to potential failures and gain insights for better decision making. It's crucial. As DJ already highlighted, our energy grid is critical, and the aging equipment and risk of failure needs to be managed proactively. Industrial IoT helps asset managers to bridge the gap between reactive maintenance and scheduled maintenance by carrying maintenance not too late or too early, but just on time. Predictive maintenance can help us estimate the time to failure to determine remaining useful life of an asset, anomaly detection. You can also make sure that the right parts are on order and ready for when a fault does occur. This increases operational efficiency, reduces service and maintenance costs, and improves regulatory adherence and sustainability. So throughout this webinar, we've examined actionable insights some best practices and studies that show the transformative power of digitalization strategies. WIKA and LORIOT's combined solution offers an extensive knowledge pool and partner ecosystem. LORIOT's been at the forefront of LoRaWAN and mioty from the start, and we ensure a safe and secure solution at our network management system is built 100% in-house from the ground up. It is not built on an open source variant, and we don't outsource. This is why we're ISO 27001 and 9001 certified, and we back that up with 5 million Swiss franc cybersecurity insurance to protect us and our customers. Each major software release exceeds a third-party security assessment and penetration testing, and this gives you the peace of mind in an on-premise deployment with a tested and proven track record to deliver robust and efficient solution for your digitalization and process needs. Now we can hand over to Dario.
Thank you. I take back control of the presentation, and yes, I invite Ingi and Dagjan to virtually join me on stage for the QA session. Before starting with the question, and so I give also some time to the attendees to write their own questions. I would like to say my three main takeaways from this webinar, and one of these is the holistic approach that WIKA and LORIOT together has, this end-to-end approach to this specific problem. So from data from measurement to value. So it's taking into account every step of the architecture, every single things, and the experience, the ability to cover so many kind of substations and appliances to address this specific challenge. The second takeaway is the impressive, at least for me, it was impressive with Dirk-Jan represented the impact of this solution in reducing cost, of course, which is sometimes the main driver for a company to adopt a solution, but also the impressive impact, positive impact in the environment. I'd like to call it the triple impact of IoT. So in the environment, reducing emission and leakages, and as also Dirk-Jan highlighted, in the safety of the people working in this environment, industrial environment. So it's again, one more time, a very exceptional representation of the impact of IoT can have. And the third takeaway I'd like to highlight here is this flexibility that an IoT network allows. As Ingi perfectly explained, once you have a network, a coverage, LoRaWAN, IoT coverage in your site, it opens a wide range of other possibilities in terms of other solutions that are available. And one question that is that I have, and I want to address to our speakers, is how this end-to-end solution address the data privacy and confidentiality issues, and how, and for the switchgear systems.
You take that one, Ingi, or?
Yeah, so it is all GDPR compliant. So this data that comes in is encrypted. It's only decoded by the one that has the keys. So it would be protected data. And as we mentioned about the sort of AES 128-bit encryption, LORIOT also adds TLS 1.2 encryption between the gateway and the network server. So security is a big focus for us and for our clients.
And I think that also probably on-premise deployment is also a key in this sense, because it gives full control to the clients. Another question, we touched this in the presentation, but maybe we can add some more details here. How predictive maintenance, which role play place predictive maintenance in switchgear systems. This is probably better for Bergjan.
Yeah. Yeah, well, what sorry, what I can say about this is until today, a lot of reactive maintenance is done, time-based maintenance is done. That means that all the operators, they are scheduling the yearly maintenance. But if you take in consideration that besides the yearly maintenance, service technicians, they need to be on site and do the manual readings of the gas density monitors 3, 4, 5 times a year. So that means that if you have an X amount of substations, X amount of switchgears, you need to go from switchgear to switchgear to switchgear. So that means you will have a lot of cost on personnel, on driving. You need to do you need to write down the values. And it's also about reliability, because if you ask 10 people to do the reading on a gauge, you will get 10 different values. So it's all, so it's, I mean, it's, we all recognize it. Hey, hey, it's just us, we are people. So everybody will interpret a value in a different way. So if you do it completely digitalized, you will have a uniform way of working. You will save a lot of cost on traveling, on maintenance work. And if you look at today's situation, I mean, there is a lack of resources, a lack of people. So if you can reduce the amount of maintenance work by having a full implemented solution with the forecasting behind it, then the forecasting is supporting you to tell you when you need to schedule your maintenance. And it's not on within 1 or 2 months. No, it's in a time frame of a couple of years that we can tell based on the historical data when you need to schedule your maintenance. So that is a completely different approach, as I mentioned in my presentations. Get away from the time-based maintenance and focus on condition-based maintenance, or more predictive maintenance. And that is going to support us
and probably,
to reduce. Yeah.
Probably also avoiding a lot of unwanted failure, unpredictable failure.
Yeah,
no?
yeah, absolutely, absolutely. Because at the end, it's all related to our sustainability. And if you look at the complete power and utility market, I mean, and just check all the annual reports. I mean, it's on, I would say, the top 5 priorities of our customers that they need to work on this sustainability program.
Yeah, and in this case, I mean, I was astonished by the data you shared about how much this reduction is really affecting the comparison you did with how many kilometers we have to drive, or how many acres of wood to plant. It's really amazing, and this is, I think, it's only this one point should say encourage the adoption of such solution. And talking about solution, we have said that a network, LoRaWAN or mioty network, allow several solutions, several use cases in the same site. So I would like to ask Ingi if there are best practices to take into account when it comes to manage different use cases of, or with the same network, with the same infrastructure, or some, let's say, tricks, I would say, to reduce battery consumption of the sensors or optimize the infrastructure in the network.
Yeah, typically you want to start by examining your use case and kind of look at how many devices you're going to have, how often they're transmitting, and then decide if you need high availability and redundancy in your network as well. Some use cases are more critical than others. Sometimes smart metering, maybe they only want 2 messages per month per device, as whereas other things are a bit more critical, maybe parking, they want to be polling every minute or so. So kind of knowing what the use cases you're going for, what devices you're using, and all of that, that can really start you off with the proper network planning to ensure that you're using a good spreading factor and adaptive data rate when you actually go to your production environment.
Thank you. I don't see at the moment any question from our audience. I remind that they can use the chat or the QA session, the QA tool in the webinar. I don't know. In the meantime, if Derjan and Ingi they want to add something, or in case there are no questions, I can move forward. And of course, if any question arises, we can always ask you. So moving forward, I'd like to remind everyone that if they want to deepen or start their journey in mioty, this new technology that Ingi was talking about, I remind you we have next free webinar very soon, the 7th of May at 4 o'clock Central European Summer Time. Here you have the QR code to register, and I also shared the link in the chat. And so if you're interested in this technology, I invite you to join this webinar as well, organized together with the Mioty Alliance. And we will have as speaker Professor Jörg Robert from the Technical University of Ilmenau, and Daniel Sabot, my colleague here in LoRiOT, that was leading the team that developed together with the Mioty Alliance this new tool, Mioty Code, that, let's say, accelerate the adoption and the test of this new technology. Again, moving forward, I would like to remind to all of our attendees that on September 19, we will host in Valencia, but is also available online, the first IoT Spark conference, focusing on 4 topics, mainly sustainability, smart city and utilities, industrial IoT, and logistics. I also like to highlight the role of WIKA as diamond sponsor here, and I'm gonna share also the link to the event website if you like to discover more and eventually, hopefully, attend and meet all of us there in person. And I think that's all covered from my side. Oh, look, there is last minute question. Will presentation slides be available afterwards? Thank you, by the way, for the great presentation, which I extend to our speakers. Yes, we can send the presentation, but we also make available a recorded version of this webinar, so you can check and see and jump to the moment you want to replay as you want on demand. It will be available ready today in the afternoon probably. And yes, we can also share the presentation. Of course, you can benefit from the present of our speakers now. If you have a question, they will be, for sure, we have still time, and they will be sure happy to answer. And also, I can invite you to connect with Ingi and Derjan on LinkedIn. They're both on LinkedIn, and they will be happy to connect with you and set up or arrange a meeting if necessary, if you're interested in this solution at any moment. I see someone writing. That's why I'm waiting, because this is what happens every time. So I'm ready to say to the final greetings, and everybody starts writing. Let's see, no, anything? Okay, perfect. So what else? Thank you to everyone. Thank you to Ingi and Derjan for joining me this live webinar. Hope it was interesting for you all. And as said, the replay, the recorded version of the webinar will be available soon. So follow also WIKA and LORIOT on LinkedIn to stay updated on the release. Thank you very much, and see you on the 7th of May for the next one. Bye-bye.
Sure, everyone.
Bye bye, everyone. Thank you. Bye.